Ừ. We're gonna start in like maybe 5 minutes.
Okay, hello everyone. Welcome back to ACSL. So it looks like that we around have everyone here, maybe just one or two. So let's just go ahead and start today's lesson. So everyone can hear me all right?
Yes.
That's good. So let's first see, does anyone have any questions on the homework or specific problems that is challenging?
Wait, there was homework?
I mean, it's more like practice. It's sort of like homework, but like there's practice questions. So yeah, it's in Google Classroom right now. So you guys can always look back to it. There's just a series of questions that you guys can use as practice. It's okay. So would you guys want me to like shortly review on last week's content?
Yeah.
Okay, so it's just a pretty short review. So how about Octo? Okay, so right. So for all three types of computer numbering system, decimal, binary, octal, and hexadecimal, our first step would be to first make a chart. In this case, our decimal number will be 236 base 10. We're trying to convert this number to octal. So our first step would be to find the powers of these numbers. So like for 8 to the power of 0, 1 to the power of 1, 8, to the power of 2, 64, and to the power of 3, 512. So we first check what is the highest power that can fit into this decimal number. So let's say that we first try 512, but because 512 is larger than 236, it can't fit in. So then we'll try our next one, which is 64. So then 64 can go in. So that's actually the highest power of 8. So I would recommend to write down all the powers of the computer numbering system that we're working with. Like for octal, it would be 8, binary 2, and hexadecimal 16. And to keep track of what power we're on. It's just a short review, so I'll probably skim through it because we also have our own lesson that we need to go on for today. So then basically we'll look for our highest multiple. So since our highest power is 64, then we just look for a number that multiplied by 64 can fit into 236. So if we try 4, it would be 256, which is too large. It can't fit in. So let's try one number down, 3. That would be 192. So this can't fit in. So this would be the highest multiple that can fit into this number. So that means our first octal number would be 3.
I have a question.
Yeah, go ahead.
I just want to know how I thought it was just like 8 times 8 times 8, and we find the answer and we subtract it like that. But how'd you get a 3?
So basically our first step is to look for the highest multiple. So we'll first look at these numbers. So in this case, out of these 4 numbers, 64 is the highest that can still fit into here. Our next step would be to find the multiple, and this is how we would find this number. Does that make it more clear, or?
So you mean like multiple of the decimal number?
Of like the power number, yeah. So like for 64 is basically equal to 8 to the power of 2. So to the power of 2 would be its highest power. And then our step 2 would be looking for its multiple. In this case, 3 times 64 will get us the highest that can still fit into our decimal number.
Okay.
Okay. So let's see. Damon, is that how you pronounce your name? Yeah, go ahead. So
Yeah. So basically the listed numbers like 64, 8, and 512. So you just use those numbers and then multiply them by different numbers to make it closest to 236.
yeah, so our first step would be to check which one is like the largest that can still fit into here. Like 512 is too big. So then our next one would be 64, which is the highest. And then our step 2, we will look for what can multiply with that power number to get us closest to this decimal number.
Okay, I understand.
Okay. So we'll save this multiple as our octal number. And then we'll subtract our number. Since previously our highest was 3 times the power of 64, this will give us 192. We will subtract our decimal number by the highest multiple. In this case, it will be 192. So after we subtract it, that'll give us our next decimal number of 44. And then we'll repeat these steps. So 44, we'll just move down a power. Since previously we were on 8 to the power of 2, then we just move down a power to 8 to the power of 1. This is equal to 8. So then we'll find the highest multiple that can fit into here. In this case, it would be 5, since 5 times 8 is equal to 40, and this is less than 44. This is the highest that can get to this decimal number. Any questions so far on this short review?
I have a question.
Yeah.
So like so then 8 times 5 is 40, right?
Mm-hmm. Yeah.
And then does it work like 44 minus 40 equals 4, and then we do like 8 to the power of 0, which would be 1, and then we multiply that by 4?
Yeah, so basically for our last one, after we subtract this will give just like you said, this is 4. And since 4 can't fit into any power of 8, so other than 8 to the power of 0, but since 8 to the power of 0 is 1, we don't really count that. So 8 to the power of 1 is just 8. So since 4 is already less than 8, then that would just be our last octal number. Okay.
Okay, thank you.
So then, like, we just put these numbers together, and that'll give us our octal number. So it's basically the same thing, just that it's a little bit different for the other ones. Like for binary, it'll be true or false. And for hexadecimals, it's the same thing. So then how about we move on to today's topic first? And if there's any questions, you guys can always post on the Google Classroom. Move on to today's topic. All right. So last week we talked about converting decimals to non-decimals, and we first we learned how to convert decimals to non-decimals. Last week we learned how to convert non-decimals to decimals. Now we'll learn converting non-decimals to non-decimals. So non-decimals are just the other computer numbering systems, like octal, binary, and hexadecimal. So let's first have a mini lesson about leading zeros. So how about I first ask this question? So what is 0, 0, 1, 2, 3 equal to in normal math? You guys can just type your answer in the chat, like A, B, or C.
Can you repeat the question?
Oh yeah, sure. I might be going a little too fast. So okay. So the question is basically what is 0, 0, 0, 1, 2, 3 equal to in normal math? We're first having like a mini lesson about leading zeros.
I think I know. I think I know.
Yeah, you can type it in the chat and then we.
Oh, okay.
Yeah. Okay. So I see a lot of B's, and that's the correct answer. So the idea of leading zeros is that any zero in the front, it just doesn't matter in any numbering system. So like for example of this binary number of 0, 0, 1, 1, 0, 1, 0 is just basically equal to us just dropping these front two zeros. Okay, so everyone understands this concept, right? Because we will need this for later on. Yes, you raised the hand. So.
I don't understand the like the 0, 0, the 0, 0, 0, 1, 2, 3. Like how it. I don't understand how it's equal to like a normal math. Like how does that work?
Because in normal math, we would also treat these zeros in the front as it doesn't matter. So like if we had 0, 1, it's just basically the same thing as 1. Or in this case, like 0, 0, 1, 2, 3, since we don't have another number in the front here, so if it's just zeros, then it doesn't matter. So we can just leave it alone and we can just drop it. We can just ignore it. Does that make sense?
Yeah.
Okay. So let's first learn how to convert binary numbers to octal numbers. So let's use this binary number as an example. So when we're converting binary to octal, we will use this grouping strategy. For binary, when we're converting to octal, we would group these binary numbers into groups of 3, starting from the right. So in this case, we will group them 1, 0, 0 for our first group, 1, 0, 1 as our second group, and then our last number will be 1. That is when our concept of leading zeros comes in. We would add leading zeros until this is full of 3 digits. So this will be 0, 0, 1, and that will be our last group. Make sense? Okay, and then our next step would be turning groups into decimals. So when we convert 0, 0, 1 base 2 into a decimal, it will be 1 base 10. This one is just like what we first learned about converting, what we learned last week actually, converting these non-decimals to decimals. And then we will do the same for the other 3 groups. 101 base 2 is equal to 6 base 10, and 001 base 2 is equal to 1 base 10. And then to get our final octal number, we would just put these all together, not add them. We would just put them all together. So our final number would just be 161 base 8. Okay. So is there any questions? I might have went a little too fast. So you guys can always tell me to slow down if I'm going too fast. Yeah, Jonah, you raised your hand. Do you have a question? So is there any questions about this so far? Or okay, let's see. We get 6 for number 2. For number 2, we would convert this. So let's see. This would be 2, 0, 1, 0. 2 to the power of 2 would be 4. I see. I think this is actually 5. Wait, let me check. So for when we're converting 2 to the power of 0 times 1, 2 to the power of 0 would be 1, 2 to the power of 2 would be 4. 4. Yeah, this is actually 5. Turns out.
Wait. Is it okay if you explain that again? I don't think I understand it.
You're
Sorry.
saying converting binary to octal?
Yeah.
It's okay. So we would group since we have our binary number, we would group it into. So for our binary number, we would group it into groups of 3. So we would count from the right. So we'll count 3 digits: 1, 0, 0. This will be our first group. And then we'll count our next 3 digits: 1, 0, 1. This will be our second group. And our final 1 digit would just be alone right now. But since we also have the concept of leading zeros, we would add zeros to this until we meet this 3-digit per group requirement. Okay, so far so good. And then our next step would be
I still don't understand it. Sorry.
it's okay. So you see how our binary number is just made of 1s and 0s? For converting this binary number to octal, we would group them into 3 digits. So we'll count 3 digits from the right. So 1, 0, 0. This will be our first group. Our second group would be our next 3 digits, which is 1, 0, 1. This will be our second group. And our last digit is actually just a 1, but we would add leading zeros to this until we meet that 3-digit requirement. Is there a specific part that I should explain again?
No, we're good. Thanks.
So is there any question? Does everyone understand to the steps so far? Because this is basically the most important.
Kind of, not really.
It's okay. So we're just basically counting 3 digits and grouping them into different groups. So we'll count 1, 2, 3 digits, 1, 0, 0. This will be 3 digits. This will be group 1. And we just count another 3 digits, 1, 0, 1. This will be group 2. And then our final one would just be a singular 1. But then we would add leading zeros, just like our mini lesson that we just said. We would add many zeros until this reaches 3 digits per group. And then that'll give us 3 groups. Okay. So then afterwards, our next step, since these groups are currently in binary, we would convert these binary into its decimal form. So like for our first group, 001 base 2 is equal to 1 base 10. This is a mistake since 101 base 2 is actually 5 base 10. And our last one, 0012 is equal to 1 base 10. Sorry if this is confusing. Let me really quick change that so it isn't as confusing. Actually 5. Our number is actually, so our final number is actually 151 base 8. Alright, so is there any questions right now? Or is there a specific part that I should go over? Okay. Yeah, it's okay. It is a little confusing. So is there a specific part that I should explain? Like, is it grouping or is it converting? Yeah, Damon.
It's both grouping and converting. I'm kind of confused on.
It's okay. So we all remember how to convert these non decimals into decimal numbers, right?
Yeah.
Yeah, so this is just how we would do it normally. This is just normal binary to decimal conversion. And then for our grouping part, this is probably like the harder part. So it's just basically grouping them into groups of 3. So we would just put parentheses around 3 numbers to signify a group. So let's say we
Oh, so basically you just group the numbers like right down here.
so we just group them into digits of 3. So you just separate them into digits of 3. And like for our
Oh,
since it only is a 1, we would add zeros, our leading zeros, until it meets that requirement of 3 digits per group.
does it have to be in a certain order?
Yes, we're grouping from right to left. Since
Oh, okay.
we'll start from here, we'll start from the left and convert it, and we'll convert over to the right, and this will give us our number, and we'll just put them all together, and that'll give us our octal digit. This is just perfect how it's 151, so no matter what way we put it, it will still give us this. But it's not always like that, so our grouping will be from right to left, and when we're converting, we're starting from our left one. Okay. Is there any questions?
I understand the grouping part.
Okay, that's good. So does everyone understand this? All right, Jonah, you raised your hand. All right, so does everyone understand this? Like, Jonah, do you have a question? Okay, so it's okay. I can briefly go over it. So basically, for our number of 1001, let's do our number 1001 base 2 to base 10. So when we're converting, like no matter what, like computer number system we're doing, our first step would be to be counting the positions from right to left, starting from 0. Oh yeah. Sorry, I forgot. 1 sec. Okay, I sent it in the chat. It's currently processing. I'll first wait for the link to go into the chat and then continue. Alright. Yeah, so the link is currently in the chat, so you guys can just click on the link to see the Jamboard more clearly. Okay. So let's say they're trying to convert this binary into a base 10 number. We're going to convert this into a base 10 number. So our first step would be to take the 2 to the power of its base, 0. 2 to the power of anything is just equal to 1, and we multiply this by the binary digit of 1. So does this refresh any memories? Okay, I'll still go over the whole problem. Don't worry. So then our next step would be bringing 2. So this, our first number, would be 1. 2 to the power of its position of 1. This would be 2. And then this digit is of 0. So anything multiplied by 0 is just 0. This number is 0. Then now let's move on to our last digit, which is, we'll first do 2 to the power of its position of 2, which will give us 4, since this is just basically 2 times 2. Then we'll multiply this by the digit of 0, and same, whatever we multiply by 0, that just give us 0. So this digit will give us 0. And then our last step to convert this into decimals is just adding the 3 numbers that we have together. So our 3 numbers here that we found from here, we just add them all together. And that will give us our final decimal number. Alright? So does that refresh memories? Does that bring...
It's really confusing.
So you're saying converting binary to decimals, right?
Yeah.
So basically, our first step would be to bring, for binary, we'll bring the power of 2 to, we'll bring 2 to the power of its position. So let's say the first one, it will be 2 to the power of our, let's first do the first digit, which is at a position of 0. So anything to the power of 0 is equal to 1, and we'll multiply this one by the digit of the binary number here of 1. And this 1 times 1 will just give us 1. Yeah, so John, so basically all the zeros give us 0 because we will multiply our, since our first step is always bringing 2 to the power of its position, and we will multiply it by our binary number. In this case, it will be just zeros. So anything times 0 will just give us 0. So these zeros will just give us 0. So is this still confusing? Or should I try the other numbers too? Okay, so let's see. So how about I also convert the other 2 numbers? So our second number was our second group was 101 base 2, and we first converted into a base 10. So just like before, our first step would be counting our positions from right to left, 0, starting with 0, 0, 1, and 2. And then afterwards, we will bring 2 to the power of its position of our first digit. In this case, it would be 0. And anything to the power of 0 would give us 1. We would multiply this by our binary digit of 1. This will give us 1. And then for our second digit, same, we'll start with 2 to the power of its position of 1. This number will give us 2. And then we would multiply this by the binary number of 0. Anything multiplied by 0 will give us 0. I should probably mark this right. So for this one, this 1, this first digit will give us 1. This second digit, which is what this second digit, and this second digit will just give us 0. And then for our last digit, we start with 2 to the power of its position, 2. And then just like here, 2 times 2 is equal to 4. And then in this case, we multiply this number by its binary number again. And here, for this number, it is 1. Multiply this by 1, and 4 times 1 is equal to 4. So our number here, this number that will give us is 4. So far so good. Is there any questions? Okay, so it's still very confusing. So basically, our first step, you guys know how we start with counting the positions. We start from right, we're going to left, we're starting from 0. And these would be your positions. we will first bring 2, is this binary, to the power of the position of 0, since we're trying to find what this first digit gives us. So 2 to the power of its position of 0, and then anything to the power of 0 will give us 1. We would take this one and multiply it by this number. We will multiply it by our binary number of 1. And then when we multiply them together, that'll give us 1. So then we just save this one, and we just save this one right here, and we first find what these other numbers give us. Okay, so is there still any confusions? Is there like a specific part that I should explain more in depth? Okay, so how about I first finish this one? So our final step would be to taking our saved numbers. In this case, it would be 4, 0, and our 1. And then we would add them all together to get us our decimal number. So our number of 4 plus number of 0 plus our number of 1. And when we add them all up, this will give us 5. So our second group will give us a 5 base 10. So it's still very confusing. Is there like a specific part that confuses you guys? Okay, so how about let's do the last one too, and I'll try and explain more in. So our last number was 0, 0, 1 base 2, right? It's okay. So basically, we're trying to convert this binary into a base 10, a decimal. So our first step would be to count its position of 0, 1, 2, since we're counting from right to left, starting from our 0 and counting. So this will give us our positions. Let me split this part first. So let's first try and find this digit, what this number gives us. So our first step to finding what a number will give us is taking 2, this is binary, to the power's position right here that we counted earlier, which is 0. And then anything to the power of 0 will give us just 1. Our next step would be to multiply the binary digit 1 with this number. So in this number will give us 1. We would save this number right here. So we just save right here and remember that the first digit just gave us the number 1. Okay, so far so good. So this since basically the other 2 is just doing the same thing. Is this a little more clear, or is there still confusions and it's still confusing? It's okay. Don't be scared to ask. It's still confusing. All right, that's okay. So let's say. So what part would you say is confusing? Like just figuring out how to find this number right here. Okay.
I'm confused on the binary to octal part.
Oh, okay. So how about I first ask if there are any more questions about converting the binary to decimal part first? Okay, so I'll first finish this problem, and always feel free to ask questions in the chat. So how about let's do our second digit now. So our first step would be to bring our 2 to the power of position, which is 1, and 2 to the power of 1. This would just give us 2. We multiply this by our binary digit. In this case, it would be 0. And anything multiplied by 0 would give us just 0. So no matter how big this number is, it would just always give us 0. So that means we just save this number of 0. We just save it. We just keep this as 0. And then lastly, we would also convert our last number. We'll also find out what our last number is. So 2 to the power of position 2. This will give us 4, as is just the same as 2 times 2. And then we will multiply this number by our number right here, our binary number of 0. And just like above, any number divided by times 0 will just give us 0. And then to find our final decimal digit, we would add all three of these numbers together. So 0 plus 0 plus 1, this will give us a final number of 1. So when we convert this to decimal, it will be 1 base 10. All right, so is there still any more questions about converting binary to decimals? All right, so how about let's go back to converting our binary numbers to octal. All right, so does everyone get how to group the numbers?
Yes.
And then we also just went over how to convert the decimals in our binary into decimals, correct? So everyone also understands that part? Yeah, so basically our last step is just to put them together. We don't add them together, we just put them as the same number. We just put them side by side. So like our numbers are 1, 5, and 1. We just put them side by side and put a base 8 since we're converting to octal. So our final number is just 1, 5, 1 base 8. So is there any questions about this so far? Our binary to octal? Right, like a part or any part of it, either be converting binary to decimals or just grouping the numbers. Don't worry, on the Jamboard, those are just to hide people's identities. So is there any more questions, or should I just move on? So let's move on if there isn't any more questions. So our next one will be to do the other way around, which is converting our octal to binary. So let's say that we're trying to convert this octal number of 671 base 8 to base 2. Our first step would be to also group it, but instead of last time grouping it in digits of 3, we just group it into individual digits. So like 1 as its own group, 7 as its own, and 6 as its own. Then we will split these numbers into binary. So we're just basically converting these octal numbers into our binary numbers. This part might be a little confusing. So do you guys know how we got these numbers? Do you guys understand how to convert like octal to binary, this part? Yeah, it's okay. It's understandable. So you know how so far I would suggest maybe first try converting the octals into decimals and decimals into binary. Okay, so there's actually okay, so let's see. Maybe I should try going over this. So how about let's first try going over the first. So our same Jamboard. So let's just first try converting our 6 base 8 into a base 2. So our number is 6 base 8, and we're trying to find a way to convert it into a base 2. Base 2. Base 2. So I'll suggest so far for the first step is converting this into a base 10. And we'll use the method that we just learned earlier, which is like counting the positions. Since we only have one number, this number has a position of 0. Taking 8, since it's octal, to the power of position of 0. This will just give us 1. Anything to the power of 0 will just give us 1. And then we'll multiply this by our octal digit of 6. This would just give us 6. And since we only have one digit, we don't need to add anything together. So our answer is just 6 base 10. So far, so good. We're converting our octal to decimal. And then to fully convert this, we gotta also convert our 6 base 10 into a binary number, base 2. Alright, so far so good. So just like as we learned last week, our first step would be to first write out the powers of 2. So 2 to the power of 0 would be 1, 2 to the power of 2, 2 to the power of 0 would be 1, 2 to the power of 1 would be 2, 2 to the power of 2 would be 4, and then 2 to the power of 3 would be 8. So we will first test out which one of these powers it can fit into here. So since this is binary, we wouldn't actually search for the multiple. So in here, let's first try 4. So 4 is the highest that can fit into our decimal number of 6. So since this can fit in, that means it's true. And in binary, we represent true and false with 1s and 0s. Is there any questions?
No.
Right. So since we're testing out, so our highest power of 4 is basically equal to 2 to the power of 2. Since this can't fit into our 6, so then our first number of binary will be 1, since this is true. And then we'll move down a power to 2. We'll subtract this, so 6 minus 4, this will give us 2. And then we'll check if our next power of 2 can fit into here. So can our next power of 2 fit into our decimal number of 2? So for this number, yes, our next power of 2 can fit into here. So this would just give us another 1, since this is true. And then we subtract it by 2. This will give us 0. And since no longer any power of 2 can fit into here, so this should just be 0. So that's how we got our 110. And then we would do the same with our other 3 numbers. Is there any questions? If there isn't any questions, I'll just move on. So, and then our next step is just to combine them, like before. We just combine them and not add them together. We just combine them and put them side by side. And when we write it out, it'll just be 110, 111, and then 001. And that's how we convert it into binary. Yeah. So for today, we'll end around 8. So does everyone get how to convert binary to octal or octal to binary? Like either about converting or just grouping. Don't worry, you guys can just ask questions. there any questions? Because it's best that we understand this well, because later on, our next one, like when we're converting hexadecimals, is basically using the same concepts. That's okay. So you, so Damon, you understand how to convert binary into decimals, right? So you understand how to convert the binary to octal part. And then probably the harder part of it too. Okay, so probably the harder part of it too would be octal to binary, because we also, since we need to figure out how to convert this octal number into a binary number. So does everyone understand the example that I showed earlier, or should I also do maybe like the second number of 7 base 8?
We can move on.
Alright, so is there any questions? Like, it's okay if you don't get it. I can just go over it. Alright, so does everyone understand how to do this? Because like when we're converting hexadecimals, we're sort of using the same technique. So it's best that we are familiar with this and we understand this. It's okay. So for basically, how about I'll also convert our second number of 7 base 8. Oh, I see. Okay. So let's go back to binary to octal real quick. So let's see. So Damon, so you understand the grouping part, but you don't really understand the, let's see. So you don't really understand this part, right? To converting the,
Yeah, I understand grouping like the numbers, but I don't understand how to convert the groups into decimals.
yeah, that's okay. So let's see. So in my Jamboard page, I split into multiple pages, and you guys see how there's an arrow up on the top, I think. You guys can always just click the arrows and flip between the pages. Every single page is like a different example or a different problem. Okay, so let's see. So is there any more questions from anyone else? Or does everyone already understand this? Sorry, Damien, I'll still go over your converting binary to decimal. Okay, so let's go over this again. So how about let's just convert our first number again. Let's convert our second group actually, since that is a little more different. And alright, so our first step would be to count positions. Position 1, this would be position 2. Our first step would be to do 2 to the power of its position, since we're first trying to find what digit this gives us, what number this digit gives us. 2 to the power of its position of 0. Anything to the power of 0 give us 1. We will then multiply this number by our binary number of 1 right here, and this will give us 1. So basically, after we find out what this digit is, we will just save this number for now, and we will find out what these other two numbers, like the other numbers, give us, and then in the end we will add them all together to find the decimal number. Alright, so Damien, do you not understand how to convert binary to decimal, or like our next slide, which is octal to binary?
I don't understand both.
So this might be easier than octal to binary, since octal to binary basically have to do it 2 times right now. So let's first go over this. So do you understand what we're doing so far?
I kind of want to know what the difference between both is and how to do it.
So basically the difference between both, so far we learned, is just all based around our decimal system. Either be converting non-decimals to decimals or decimals to non-decimals. So for when we're converting binary to decimals, we just do this normally. But if we were to do our converting octal to binary, since we have always just been learning surrounding around how to convert to decimals or convert from decimals, we have to basically do it twice, first converting our octal number into a decimal, and then converting our decimal number to a binary number. All right, so far the concept, you understand it, right?
A little bit.
All right, so do so far do you understand like what we're doing with converting our binary number into our decimal number?
I still don't get it.
Okay, that's okay. So basically what we're trying to do is find out what number each digit gives us. So we will run through this equation like thing, and we would find out what number this gives us. We will save it, and in the very end we will just add them all together. Like for our second digit, for our first step would be to do 2 to the power of position of 1, and then we just take this to the power. 2 to the power of 1 is just 2. And then we'll multiply this by the binary number of 0. And then we'll take, since anything multiplied by 0 will just be 0. So now we know what our second digit gives us. Our second digit gives us a number of 0. We'll also save this number for now. So far, so good?
A little bit.
So basically, we're just gonna keep on doing this on repeat until we find out what number each digit gives us. So like for our last one, once again, we will do 2 to the power's position. In this case, it would be 2. And then you understand exponents, correct?
Yes.
Alright, so 2 to the power of 2 is the same as 2 times 2, and this will give us 4. And then let's say our next step then will be multiplying this number that we have here by our binary digit of 1. We multiply this by 1, this number will give us a final number of 4. And then we will also save this number, so this digit will give us the number of 4. So currently we know what number each digit will give us, and we have saved them all here. And then to find our final decimal number, we would just add them all together. This is not 2, this is 1, and then this would just give us a 5. So this is equal to 5 base 10. So for this one, we would add them together, like just doing normal addition. But like when we're converting, we just combine them together. So I'll say, how about I just say, we'll add them is like our addition. And when we say we combine them, we're just putting them side by side. Okay, so I'm not sure if I say your name correct. So Han Xian Pei. So is there like a specific part that I should explain? And Damien, do you understand it right now, or is there still confusion?
I understand half of it.
Half of it in what way?
I understand the last part you said, like 2 to the power of 2, and then if you do an exponent, like a number to the power of a number, that answer you get, you multiply it by the binary base.
Mm-hmm. The binary digit. Since
Yeah, the binary digit, and then you do that number times that number, and then your answer, and then you add it by 0, and then the I forgot the other part.
Yeah, that's sort of basically just the main idea. Like we would do it like in this case we'll do it 3 times to find out our numbers, and we just add them all together. So that's just basically the main idea. So your understanding is actually correct. But do you understand how we got 5?
Yeah, I understand.
Alright. So is there any more questions about converting? Since we're probably going to do a lot of converting with computer numbering systems. So how about today we just clear up some questions about like converting just binary to octal or octal to binary. So far everyone understands how to convert binary to decimal first, right? Or is there still any questions or anyone that still doesn't understand how to do? Okay, so binary to octal is just basically split into 2 parts, just like here. So our first step would be to group it. Everyone understands grouping, correct? We just group it into 3 digits per group. And then our second step would just be converting it into its decimal form and just combining it. And that'll, in the end, that'll just give us our octal digit. So far, so good. So this is just binary to octal. And then our other one would be to do it the other way around, which is octal to binary. This would be a little bit harder since we need to do converting 2 times. So we'll first convert octal to decimal and then decimal to binary. Okay, so does everyone understand how we get these binary numbers? Like how we first converted it from octal to decimals and then decimals to binary?
Kind of. Or yes.
Alright, so is there any questions?
No.
Okay. And then after that, just like before, we will just combine them. We will just put them side by side. And when we write them out side by side, that'll just give us our binary number. Alright, so everyone understands how to convert binary to octal and octal to binary, right? Or is there still any questions where I should go over again? Is there any questions? Maybe any confusions? I can always just go over the whole thing again, so don't be afraid to ask. The most important thing is actually just to understand this, this first one at least, to understand it pretty well and understand how it works. Because afterwards, our next one after octal to binary would just be converting binary to hexadecimal. And we sort of use the same technique as our octal numbers. So we have to make sure that we understand how to do this and is familiar with how it works. Okay, so how about everyone understand this, correct? I know that I keep on saying it, but it's really important because we really need to know this for the future ones. Okay, so let's see. Our time is almost running out today, so maybe we can do our binary to hexadecimal. Let me see. So since today's lesson, since it's already 8 and it's the end of today's lesson, so how about we just end today's class here with just converting binary to octal and octal to binary. So how about we just absorb this information and try to get familiar with it. I believe some practice questions will also be posted in Google Classroom, so you guys can always practice those and try those. And remember to always feel free to ask questions in Google Classroom. So thank you guys all for attending, and see you guys next week for our binary to hexadecimal and our next topics. Thank you.